Okay. Today mark day 6 of our lectures, and we'll be looking at video coding with motion estimation. This topic, we will be treating two topics today, and they are very important. In fact, in every exam, it always come out. Expect questions from these sections or from our today's discussion. Expect questions. As far as this course is concerned, questions must come out from this area. So we'll look into digital video coding of MPEG, that is video standard 1. We'll look at different types of video standard, MPEG frame. We'll proceed to look at how it is being decomposed into sequence in layers. And finally, how to predict motion estimation and compensation. This is the first segment of today's discussion. We'll also take the second part, all bothered about video and its standard. Okay. All right. We look at the concept of digital video. The concept of digital video, which has been applied in different areas, such as DVD, digital TV, HD TV, video telephony, and teleconferencing. Just like as we are discussing now, my video is on, and you can see me talking live and direct. This is one of the application of digital video. Most of the video compression standards are based on set of principles that reduce the redundancy in digital video. However, in this unit, we'll look at different video coding techniques with MPEG 1. At the end, you should be able to explain motion estimation and compression. You see this, motion estimation and compensation. Motion estimation and compensation, know it very well. The principles behind MPEG video coding, know it very well. Always come out in an exam. Here we look at video compression in module 2, as we earlier discussed. Digital video is essentially a sequence of pictures displayed over time. That is in a way of defining or describing digital video. It's just a sequence of pictures displayed over time. Just as I'm talking, you can see me. It's in sequence. Within this time, I turn it on, whether webcam or camera or phone camera or any other digital devices. You can see it is a sequence of pictures displayed, as you can see me, over time. And each of these pictures of a digital video in a sequence format, sometimes it appears in 2D projections. compared to 3D projection or 3D world. Mean that sometimes any part, anyhow you turn it, you can see my one part, any part, or the edge. Sometimes if you're using phone, there are some phone that the edge, this edge here can even snap or capture an image. Even at the back here, the edge, not only this is only the camera is you can see here, only the camera. But there are cameras at the edge of it. You can also enable to capture, and it is referred to as digital video. So now we shall proceed to discuss video compression with respect to MPEG standards. Video coding of MPEG-1. Take for instance, a medium quality video with a constant total bit rate of 1.5 megabytes for storing video and audio on CD-ROM. The video part use 1.5, so let's say 1.1 bits per second, while remaining other parts, kilobytes per second, is used by audio, and these details are required in the systems. However, MPEG-1 specification is such that it allows different parameters to be chosen depending on the compromise between encoder complexity, compression rate, and quality. What we want to discuss here is, you look at different resolutions that are being used by video. Sometimes when you capture some video, the silent question is that why some videos are not clear? Why some cameras are sharper than each another? The resolution of the camera, the quality of that image, some are better than others. This depends on the device or the pixel you are using. The implication of this is that for parameters outside this range, there is less likelihood of compatibility between different encoders and decoders. Encoders, it receives; decoders, it display the output. You receive and you pass the signals. You input something and you display it. There is encoding and decoding. I may encode some certain words in a different language, but ability to decipher it, to explain it for women understand, make it readable, that is decoders. In the same way you have in your houses, some of you use decoders attached with dish or DXTV. DXTV have decoders. StarTime have decoders. GoTV have decoders, and other satellite operators. These decoders have to receive signals because the image are being encoded. If you put your CD into your DVD machine, then it is stored in the CD. On the day we look at it, even if you break the CD, you can't see anything inside because it's already encoded. When you break your televisions, you can't see anything there because those pictures, those images are encoded, but the decoders have to transmit the signals to humans readings or readable or display or understanding. So with the encoders and decoders, we can deduce the following. Horizontal resolution less or equal to 760 pixels. Vertical resolution less or equal 576 pixels. Microblocks per picture less or equal 306 pixels. Microblocks to the process per second less or equal 99,000. At the same time, frames per second less or equal to 30, where bit stream bandwidth less or equal to 1.8 megabyte per second. Then decoder buffer size less or equal to 376,832 pixels. This determines how quality, it determines how transmissions, it determines how the system can encode and decode the information. Then, these techniques refer to a prediction with movement compensation, consists of deducing most of the pictures of sequence from proceedings and even subsequent pictures with minimum of additional information, representing a difference between pictures. What we are trying to explain here is that all these things are in sequence, which depends on how each of them works within an interval of time. Fortunately, this function is not required in the decoder. They don't work in a decoder. So the different types of the standard MPEG frames, it's just an arrangement of frames, just like what you see here in figure 3.2.1a. So I would the number one prediction there is intra, number two is predicted, and number three is bidirectional or bidirectional predicted, which is B. So though some of these are not the image, the figure is blurred, you cannot really read it. Like this is prediction, this is the resolutions. So, and it's not actually readable here based on the way they imported the image. But let's look at the brief explanation of them. Okay. The idea, the intra pictures are coded without reference to other pictures in a very similar manner to JPEG, which means that they contain all the information necessary for their reconstruction by the decoder. All this is just trying to explain how some of these decoders or encoders, how they work, how they've been encoded, and how they can be transmitted. So then the other part of it is bidirectional. It can work in two ways. That is working in two ways. The pictures are coded by bidirectional interpolation between the intra and predicted, I and P, which is the picture proceeding as follows. As they are not used for coding subsequent pictures, the predicted B pictures do not propagate coding errors. Therefore, B pictures offer the highest compression rate. So all this is just try to explain how this encoder and decoder works. So, and how to reorder the pictures. I just want to go to the areas you should be paying more attention to. Take for instance, if you are to calculate microblocks, this is the layers used for movement estimation or compensation. That is to say, it has different sizes, ranging from 16 by 16 pixels, and made up of 4 blocks of luminance and 2 blocks of chrominance. Looking at figure 3.2.2b, which is this, with the picture somehow blunt. It's 8 by 8, 4 blocks, is in blocks. So, but let's look at what each of the blocks can represent. Block just as JPEG. You remember what JPEG means? Joint Photographic Expert Group. A picture is made up of blocks of 8 by 8 pixels. It is a layer where the DCT, discrete cosine transform, takes place, which is to say 1 microblocks equals to 16 by 16, using Y samples in by blocks, plus 8 by 8 sample per 1 blocks, 8 by 8 CR samples per 1 blocks, then 0 is luminance sample multiplied by chrominance sample. So this is just try to analyze some of these pictures, this image you are seeing. Okay. I just want to look at some of the basic areas, some of these ones, the areas you should pay more attention to. I think the second part of this discussion is very, very important. Nevertheless, video compressions typically operate on square shapes, which groups of neighboring pixels, which is called microblocks. Just like images are in blocks, just like it cut pieces by pieces based on the pixels, the camera you are using. All these are internally done. You might your own just to use phone and capture and watch the image. The internal mechanisms, how this works, may look abstract to our own understanding, except when you are in the industry, where you see the practicality on how it works. Okay. So this works extremely well if the video has no motions. A still frame of text, for example, can be repeated with very little transmitted data. In area of video with more motions, more pixels change from one frame to the next. When more pixels change, what happens? The video compression scheme must send more data to keep up with the larger number of the pixels that are changing. These things are just a way of trying to explain how encoder and decoder works, especially when you are transmitting an image or you are watching or you are editing them. So in summary, motion estimation involves comparing small segments of 2 consecutive frames for difference, and should a difference be detected, a search is carried out to determine to which neighboring segment the original segment has moved. So in all of this, the summary of the whole of it all is that all the pictures are in blocks, which is a sequence of frames, and or in a layer format. So this is part of how the video coding with motion estimations, that is how it works. some part of this course is sometimes when you are reading it, it will look abstract, make it so difficult for you to understand, especially when you are not into the future. As I explained earlier, just try the much you can to, even that to cram it and pass, please do. However, let's look at the major parts you should pay attention. You see this area, image or video compression standard, JPEG, MPEG, and there is a 0.263. Go and read this over and over. The last exam, majority of them came out. It's very important area. And is interesting, is not abstract compared to the previous discussion. All right. Here you look at image or video compression standard, JPEG or JPEG 2000, MPEG, which is a moving picture expert group, where the video comes up. You understand? So there is a video because the pictures are moving. You take picture, but this one is moving. And we have different versions. 1, 2, 4, 7, 21. These are different standards, and more of them will look into it. So finally, you look at H.263 standards. All right. Remember, the two main international bodies in multimedia compression areas are IOS or ISO, International Organization for Standardization, International Organization for Standardization, ISO, and International Telecommunication Union, Telecommunication Sectors, ITUT, formerly known as Committee Consultant International Telephone. This was just a French language. But you see this two standard, please note it. If you ask to mention international bodies or the multimedia compression standard, the two bodies that cares for image and video compressions, is ISO and ITUT. Very, very important to note. All right, let's move on to discuss them in details. The Joint Photographic Expert Groups, or JPEG. The standard was established by ISO. You see why it is very important. ISO, International Standard Organizations, they are the people that establish this, and it become a working rules or a governing rules that must be observed when working with pictures or video related. So the JPEG again, ISO and IEC. IEC stands for International Electrotechnical Commissions. Is the standard for still image compression. Then MPEG, which is moving picture expert groups, is a standard in ISO for digital compression system, designed to handle pictures or video or audio related. It means that MPEG handles video or audio. whereas JPEG handles picture related. Okay, so let's moving on. We'll now see JPEG or JPEG 2000. Let's see what makes the difference. So, as we all know about JPEG, the goal of this standard is to support a variety of applications for compression of continuous tone still images. If they ask you, what is the goal of the standard? The goal of this standard is number one, to maintain different size. Two, in terms of color space. Three, in order to achieve compression performance at or near the state of the art. Four, it has to do with user adjustable compression ratios. And finally, the fifth one, with very good to excellent reconstructed qualities. These five are the basic standards or the goals of these standards. Moreover, another goal of this standard is that it should have manageable computational, it should have manageable computational complexity for widespread practical implementation, which JPEG defines the following four modes of operations. Four modes of operations, which is associated with the goal of this standard. You see this JPEG, there is a four modes of operations. Most of the exam, it comes out. You see this four. Please note it. Read it over and over. Note it. You see it in your exam. Once you hear four modes of operations that relate with JPEG, go to this sequence lossless mode, sequential DCT, that is the discrete cosine transform based mode, progressive DCT based mode, and finally, hierarchical mode. What is this mode talking about, or modes of operations? What does it talk about? Say, for instance, in a sequential lossless mode, compresses image in a single scan, and the decoded image is an exact replica of the original image. You just scan it. If you're using a scanner, a scanning machine, I think that one of the apps that I like so much, in the sense that it has actually relieves a lot of people from going to cyber cafe or using the main OCR scanners to scan an image. Remember, if you use your direct camera, not all of us, in fact, using the direct camera, most of the cameras cannot, when after capturing it, save the files, especially if it's a document, a text document. If you look at the background, it will be looking blonde, as if there is a white, gray colors at the background. But if you use main scanner, you discover that it will not be like that. Take, for instance, if you use one of the apps called Cam Scanner, is a digital applications that enable you to use your phone, capture an image, a document, and to look original, very much original. By the time you print it, you see, no matter how you compress it, when you print it, it will maintain original brightness or neatness. This is all this what we refer to as sequential lossless. It's lossless, doesn't lose its originality. That's why we say sequential lossless mode. It covers image just in a single scan, and it will just decode it, show it to you exactly. It look like original image. Okay. So the second one is sequential DCT-based mode. This one compress images in a single scan using DCT-based losing compression techniques. What happens? This gives a decoded image that is not an exact replica, but an approximation of the original image. This one won't give you exact, but it will look like the original image. Remember, when you scan original document and you use a scanned work, maybe you printed it out and scan it again, the compression will not be the same. Or when you make a photo, when you use your original document, you make a copy or a colored photocopy of that image. When you snap it and print again, it will not look the same. That is why a lot of people that will go and forge a result. With this measure, you will be able to dictate it easily. So, especially when you add some security background check, so it will be difficult for someone to mimic or forge that result, except you use some high-tech digital tools to manipulate it. Then what progressive DCT-based mode discuss about? It allows for the compression of images in a multiple scan. Remember that the first one only scan a single scan. The second one does a single scan, which try to replicate the original image, but the first one represents the original image, the exact replica. But this one is try to decode it, a kind of an approximation to that image. But this one does it in the multiple scans and compress the image in the multiple scans. With each successive scan, produces a better quality image. And the last one is the hierarchical mode, which allows for a compression of images at a multiple resolution for display on different devices. Hierarchical. This one in different devices, it will be able to project the same image. So all this is what we just discussed. The three DCT-based mode 2, 3, and 4 in JPEG provide loosey compression because of precision limitations to digital compute DCT. So this is what we're just discussing here. If you read the standardization file name extension .jpeg2 for 2000, which is associated for this ISO IEC this number, then so that will be for 2000 is what they are showing, the expired extension is discussing about here. Then the next one is we'll look into is MPEG standards, which is also supported or formulated by ISO standards. And going forward, you see different versions of moving picture expert group. You see different officially known as ISO this, but from at the point it was renamed, and the pixel it can handle is 1.5. This standard was based on CD-ROM video applications. In addition, Level 3 of this is the most popular standard for digital compression of audio known as MP3. Then MPEG-1 is the standard of compression for video CD, the most popular video distribution format throughout much of Asia. This is the standard they are using. You know, sometimes when you are watching some video, some of them will be very bright, some will be blurred. It depends on the kind of digital equipment you use. Some high, some you see HD and HDD and the rest of them. It all depends on the kind of the devices you are connecting with. So for MPEG-2, this is standard on which digital television set-up box and DVD compression is based. It's based on this. Then for 4, standard was defined to meet newer challenges of object-based video coding suitable for multimedia applications. Anything that has to do with an object, it is related to this. And these virtual reality model languages, all of them are based on this MPEG-4. Therefore, this standard was concerned with a similar range of applications to those of H.263, each running over low bit rates, channels ranging from, depending on the channel you are passing through. So, and that is it. Then we also have 7. There was a popular misconception that MPEG-7 was going to be another new video compression standard. But let's look at the facts. That MPEG-7 does not define any new video compression standard. It deals with file format and metadata description of the compression of the compressed videos in order to define a standard for description of various types of multimedia coded with standard codecs. The only thing we can understand generally here is that MPEG-7, it has not defined any standard, but it's just a version. It's just a version. Okay, so then let's look at 21 standard. Okay, the same MPEG-21 standard established in 2001 recently, and that is why we have 21. Is 2001 from the same expert groups, which is aims to define an open framework for multimedia applications. However, this MPEG-21 is ratified in the standard ISO 2121000. However, multimedia framework MPEG-21 was established, and it was defined the right expression languages. All these things are what it is supported and where it was produced 2001. Okay. Now we may look at other moving picture expert group standards. We have MPEG-A as of 2007, supporting the ISO 23000. We have one of 2006, 2007. These are different standards that also established, but the most important one we use is MPEG, MP3 or MPEG-3, MPEG-4, and I think that is widely used currently. Also note this, you may be asked to explain H.263 standard. Here we are talking about, this is a video codec standard originally designed as a low bit rate compression format for video compressing. This one is typically addressing video compressing issues. Like what we are discussing now. Some of you, if you turn on your video, especially when you're in a location where you have a good network, you'll be able to see it brighter than as it is. So it supports, this is the standard that supports our connections. So I think that is all we have. However, let's look at the conclusions. That these standards are developed by experts in video compression working under the auspices of International Organization for Standardization, ISO. And is suitable for you. The major goal, developing a standard for video compression algorithm suitable for use in CD-ROM based application so that anybody who want to use it is going to be uniform. So we also say that the JPEG is joint photographic expert groups, the full meaning of JPEG. So finally, we cover some data compression standard for multimedia element images, video, speech, audio, text, etc. The standard discussed in this unit will allow for interpretability of multimedia data across systems or application domain. Then we further discuss about this standards, JPEG to 2007, we also talk about 2021, 2001, or JPEG, MPEG 21. So, and at the same time, we also look at the 80.263 standard. We compare it with 261, its predecessor 264, and all their families in order to have the better understanding of its features. When you look at all their comparisons as stated here, when you read it, you get better understanding. I think that brings us to the end of our lectures from day 1 to day 6. So if you have questions, feel free to ask. The next we may meet again is to discuss or a kind of revisions. That revision should be bothered about all we needed to do and some of the challenges we have, or maybe some likely expected questions for the exams. That is what we will look at in the conclusion stage. So if you have any question, please feel free to ask. Okay, Milia, you are raising your hands. Thank you. Go ahead.
Well done for the work, sir.
Thank you so much.
Sir, just a personal question I want to ask. You are talking about revision again. Please, I just want to get clarity because I'm really being worked out already. Is the exam still taking place on the because I'm supposed to have exam on the 19th, which is on Monday, for 853. That's on by 2 p.m. My point is, as you're talking about revision, this course is supposed to be on 21st. Are we still writing the exam next week?
I have not seen the timetable. The exam of this course, you say on 21st.
Yes, I don't. This school service is very stressful.
And
now, sir.
And today is 17th. You're having the exam on 21st, right?
This course is supposed to be on the 21st. Okay. And you are still talking about revision. Okay. I don't have a problem with.
Okay.
I don't have a problem with it. I'm very glad the way you are going about it. But the point is, please, do you have anything like that may still taking place for us to write this course?
Mine is to deliver the class. Those in the administration handles the timetable planning and other logistics. So based on the only thing that whatever you see in your timetable, you work towards what you see in the timetable. However, maybe I will upload this thing. If I have any issues, or maybe I may share more insights during through the channels, through my YouTube channels, I may drop some hints. So it will also guide you towards your preparation for the exams. However, I am solely responsible for the lectures, but for the timetable, planning, scheduling, that one is within the school administration. So thank you. Thank you. We'll talk more or have more conversation from the discussion group or from the channels. If you have not subscribed to the channels, if you have not subscribed to the channels, please try. You say?
Excuse me.
Yes, I can hear you.
Can you hear me?
Yes.
Okay, so as she has said, the exam is expected to take place on the 21st. That is next week, Wednesday. So this YouTube tips that you want, because I like how you are, I like the way you are very empathetic towards